Now we're going to learn how to do that same one sample t-test in SPSS. If SPSS is not already open on your desktop, go ahead and get it open. And we are going to import our data from sheet 2 of the Excel spreadsheet that we created in the last example. This is sheet 2 of the data set that we recently created in Excel. It has the variable name for men and then the 9 scores for the men on this test. So we're going to open sheet 2 of this data set, which has been saved to the desktop. Open that in SPSS. Once you've opened SPSS on your computer, you can open the data set by going to File, Open, Data. Now, 2 important points. One is you need to be sure to have closed the Excel file in Excel. If it's still open in Excel, this will not work. The second is you need to be able to navigate to your desktop of your computer. If you're in some other folder, this is probably not going to work either. The reason I point out the desktop is because that is where we saved that Martha Stewart Excel file. Now, the first thing you'll notice is I'm looking at the desktop, but I don't see that file. And that is because we're looking for files of type SAV. Those are SPSS files. So we need to change our files of type to Excel. And now we see the marthastewart.xlsx. That's the file that we created moments ago. So click Open. And remember which sheet we had our data on? We want sheet 2. That's the one that we formatted for our data entry. So we change our worksheet to sheet 2 and we leave checked read variable names from the first row of data. Click OK. And there's our data. We can see in the variable view that it is a numeric variable. We don't have a label yet, no values. It is scale. That's exactly what we want. So we're ready to do our analysis. So let's walk through those same 5 steps once again. The appropriate statistic for comparing a sample mean to a population mean when the standard deviation of the population is unknown is the one sample t-test. The null and alternative hypotheses are going to be exactly the same as when we did the test by hand. For the null hypothesis, mu equals 73, that the men's mean should be no different than the women's mean, and the alternative hypothesis, mu does not equal 73. Our level of significance, two-tailed test, alpha 0.05, 8 degrees of freedom. If we go to our t-table, we can look up the critical value of positive or negative 2.306. However, when we do this test in SPSS, the software will be calculating the probability value, and so we won't actually see this number in the SPSS output. But now we're ready to calculate the statistics using SPSS. We'll do our one sample t-test by going to Analyze, Compare Means, One Sample T-Test. The only value that we have is for men, so let's move that into the test variables box. And then something very important. We have to tell SPSS what is our comparison value. And in this case, the comparison value is the mean of the population, which we've already established is 73. Go back to your null hypothesis. We are saying this sample is drawn from a population that has a mean of 73. I say this is very important because if you do not enter 73, the test value comparison will be 0. And if you compare to 0, you will get the wrong answer. So we need to set our test value to 73, no other changes to make. Click OK, and the results pop up. So let's take a little closer look at the output from SPSS. We'll see 2 boxes. The first one says one sample statistics, in which we get the n, the mean, the standard deviation, and standard error of the mean for the men's sample. We see that our n was 9. Our mean was 65.67. We knew that going in, but those values have been calculated based on the data that we put into SPSS. Standard deviation of 7.75, we'll round that up, and a standard error of the mean of 2.58. Hopefully that standard deviation and standard error of the mean are familiar to you by now. You see where those values came from when we did this test by hand. Now, the one sample test box is something that is different than we've seen previously. So let's look a little more closely to make sure we understand what all of these pieces are and where they go in our write-up. The three most important boxes are the ones that I've indicated with the blue arrows. The t-value of a negative 2.84. Again, we've seen that value before, but now we see the same value has come from SPSS. 8 degrees of freedom, DF, degrees of freedom. Our probability value is contained in the box that says SIG two-tailed. We did a two-tailed test. The significance value is 022. So when we do our write-up, instead of writing p less than 0.05, we're actually going to write the value 022. So you see below the one sample test box, t with 8 degrees of freedom equals negative 2.84, comma, p equals 0.022. So let's go back to our 5 steps and see where these values fit. We calculated the statistics using SPSS, and we came up with that same negative 2.84 for our t-value. We can see that the negative 2.84 exceeds the negative 2.306, or we can see from the probability value in SPSS, the one that is less than 0.05, that this test is statistically significant. So, men score significantly lower than women on a test of indoor gardening. T with 8 degrees of freedom equals negative 2.84, comma, p equals 0.022. I have tried to stress by changing the color that the only difference in this test being done with SPSS is that we write up the actual probability value rather than simply saying p less than 0.05. And here is what our full APA write-up would look like. A one sample t-test was conducted to determine whether men, mean of 65.67, scored differently than women, mean of 73, on a test of indoor gardening. The results were statistically significant. T with 8 degrees of freedom equals negative 2.84, probability equals 0.022, indicating that men score significantly lower than women on a test of indoor gardening. This suggests a gender difference in gardening skills. What I would like you to do is look at the write-up when we did this by hand and we did it by SPSS. Notice that the write-up is pretty much exactly the same. So we're going to be consistent with our write-up. The only difference that we'll see is that p-value, the 0.22 versus the less than 0.05. When we know the p-value, we write the actual value.